Welcome to Mr. Donlon's Live Maths. So welcome maths fans, here we go again for the next round. So looking forward to some fantastic people this morning. So I'm just going to hang around a little bit before we start this morning just to get some people in, and we'll get going shortly. So just while we're waiting, I want you to have a look at this little diagram I've drawn on the screen. So what have we got here? Circles 3, space. So what is space is the first question. What is the maths term for, well, particularly 2D space? Okay, and also be thinking about the important factors that you've learned so far involving pi. What's the link between pi, and also how does circumference fit in, and what is circumference? So I'll leave you for a second to complement that. Okay, so join in, folks. Today I'm after a bit of interaction, so I want some comments back as we're going along. All right, so three watches so far. Okay, so keep them coming in. Pass word around, folks. Four watches. We got 5 watches. Keep them coming in, folks. Pass this word around. Highlight of the day. It is Maths Live with Mr. Donlon. Whoop-woo! Okay, so let's get cracking then. So I've talked about space. So what is the maths word for space? And we should have come up with 2D space anyway. 2D space is going to be area. Incidentally, that's why I chose today the music, which is 2001 A Space Odyssey. Okay, so good film, good music. Okay, well, it's a bit dated, the film, really, but the music's fantastic. And talking about space, okay, 2D. But don't forget volume, that's 3D space. So really, Space Odyssey, really 3D space volume. But we're interested in area today because circles, they are a flat space. And a flat space means area, it can be made in 2 dimensions, and 2 dimensions mean across and up, not an in part and an out part. Alright, so let's have a recap on what we've learnt so far. Okay, good morning to Lydia this morning, well done for turning up today. And we've got 3 other people. Make yourself known, folks, on the chat on the side. Okay, so let's get going. So far we've learnt about the relationship of the number pi. Now pi works out to be 3.142 with a load of other decimals to it, and we've also worked out what that pi value represents. So that pi represents the relationship between the circumference and the diameter. Circumference divided by diameter. The circumference being the outside distance. Okay, so what we need to look at today is how area is related. So we also need this value of pi. The pi comes into area of circle as much as circumference. But why does it come into the equation? What's happening? What's going on? Okay, to work this out. And we're back to this relationship here. Circumference divided by diameter is always 3.142. Otherwise known as pi. So that's really important, that relationship there within the area. So hopefully this works. I've not tried this out yet, but you can see the area of the circle is being split up into these sections here. Okay, and those of you that have done circles 1 early in the week would realize that actually these little sections are called sectors, because they're made up of a radius, and the word sector's got the letter R in. That's how I remember it anyway. Not segments, but they are sectors. So we've got a whole range of sectors. Now, what I'm going to do is I'm going to rearrange these sectors, okay, into another shape. Now, I'm going to take them, and you'll have to bear with me here, okay, and I'm going to link them together as such, kind of zigzagging the sectors. All right, now you've got to imagine as well, you know, I've made these fairly big, but if these sectors were smaller, you get a greater effect on what is actually going on. Okay, so keep this going. All right, so I want you to be thinking roughly, okay, and this is an approximate shape, roughly what shape am I making now with all these sectors, putting them together? Okay, what is the shape of this kind of diagram that I'm producing? Okay, let's move this up a little bit so you get a better idea what's going on. Here's all the sectors here, just putting them all together. Alright, and look at that. Okay, so we've put all those sectors together. Alright, and just think about now, what is the actual shape that I'm making? Alright, okay, so we've got a length. Oops, let's redo that for a second. It's kind of like we've got a length mixed up with a width. So what's got a length and a width? Really easy question here. Simplify that shape as much as possible. And what is the name of it? Okay, let's get some answers on the live feed, please. Alright, so we've got a length going that way, and we've got a width going that way, a length and width. What is that shape? What is it approximating to? A length and a width. Okay, now we're getting some answers coming in. That's fantastic. So we've got the word rectangle. Well done, people. Okay, so a few more replies, a few responses would be great. So we got the word rectangle. Well done, folks. Okay, well done to Lydia for that one. So actually, if we have a look at this rectangle now, okay, all right, we've got this length here, and we've got a width. Okay, now first of all, the width is the easy one to look for. Now, the more little sectors you have, the more it looks like a rectangle. Okay, just adjust the camera a little bit. It's a little bit blurry, I'm sorry about that. I'm going to work at that over Easter. I'm going to work at that, maybe look into getting another camera set up, but at the moment, just bear with. So, have a look at this edge here and think about where it came from with this circle. Incidentally, the radius of this circle was mapped out to be 3 centimeters earlier on. Okay, in fact, I'll just prove that with a ruler. 3 centimeters. So, the next question is, alright, if this is made up of a sector going like that, and this line represents this line, what's another word for this line here? Now I'll give you a little clue. A little cluesy time. Begins with R. R for... Okay, waiting for answers. Answers in the chat. Okay, on the right hand side. Let's go. And that's correct. It is the radius. Well done. Okay, couple of correct answers there on the live feed, so thank you very much. So the width turns out to be the radius. Okay, now that is interesting. If that's the radius, okay, what is this length here? Now, okay, now let's have a think about this one. This distance here is like saying all the roundy bits. So if we included all the roundy bits there, and this as well, all the roundy bits all together, all those roundy bits, okay, that makes the same as this distance round here. Well, half of it anyway, because we've got half the roundy bits there and half the roundy bits there. So this is going to be half of the distance around the outside. So yeah, that's correct. Well done, getting some really great feedback this morning. So that's called a circumference. So, but we've got a circumference. It is made up of both sides, and you can see how far that circumference actually stretches out. So that's half a circumference. Circumference. That's right. Okay. So now we're looking at the area. So the next question is, how do we work out the area of a rectangle? 1 second. Okay, that's right. So we've got the area of a rectangle. Okay, some correct answers there is length times width. And here's where the magic starts playing in. Okay, I think this is really magic now. We've got this system set up. We've got area equals length times width for the rectangle. So the width is going to be the radius and the length is going to be half the circumference. So let's say that's half of C times the radius. Now to finish this off and to be really cool, we've got to look now towards getting this circumference in the same sort of format. So what we need to go back to is what is the circumference. So the circumference is 2 lots of r times the pi, and that, remember, that's the diameter as well. So pi d, 2r pi, 2 pi r, 2r pi, this kind of thing. All right, so I'm going to use it in that format. I could have gone 2 pi r, that's the famous one, what people remember, but we're going to go for this one. So I'm going to replace that c there with 2 times pi times r. Okay, it doesn't matter which order we go in, I suppose. Half times, so instead of c now, I'm going to say it's 2 pi r or 2r pi or whatever we want to do. Okay, so I'm going to stick with 2 pi r because that's the one. I don't know why I wrote that, but that's the one we used to. So so 2 times pi times r, and then it's by times radius again, which is r, and then we have that. And look at that, by magic, half of 2 is 1, so they cancel, and I'm left with pi times r times r, and this is where the famous area of a circle comes in, pi r squared. So the area of a circle is the same as pi r squared, just like magic. So there's a really good easy proof of what's going on. Okay, so you can see that by splitting the circle up, the radius, okay, is the width, half of the circumference is the length, replacing half the circumference with 2 pi r. Well, half times 2 is 1, so that is simply pi r, and then we multiply length with width, and we've got pi r squared. Okay, so a little bit of, looks a little bit blurry. I'm sorry about this morning, folks. It's yeah, we're getting the right idea. So let's go through that again from this stage here, just to be on the safe side. So we've got area of a rectangle is length times width, but we know that the length of the rectangle is half the circumference. Okay, because you can see that this is made up of all those curved parts, but you've got half of them there and half of them there, so one side is half the circumference. The circumference of the circle is 2 pi r, but if we take half of the circumference, it's going to be pi r, and if we multiply pi r with r, we end up with pi r squared. Boom-tastic! What a fantastic formula, and that has to be my favourite bit of maths at GCSE. Alright, so we've established now a formula for area. So let's just finish off with how this formula can be used. And this is actually the very easy part. Once we know and understand where that formula is from, using it is an absolute doddle. A doddlus. Okay, so boom boom boom, commercial break, and here we go. Alright, commercial break time. So what I want you to do this morning for our commercial break is I want you to work out these, well, just think about it and I'll go through the parts. Okay, so first of all, we'll use this circle in a minute, but we're having a commercial break. Boom boom boom. So that's 4 centimeters width. All right, just bear that in mind. Not width, radius, 4 centimeters. Okay, just things to think about. Okay, this line here, you don't need to write them out, and we're just going to go through them, but you need to think about it, have the answer in your head, and award yourself a pat on the back if you get it right. 3, 2, 1, that line. Boom. chord. Okay, this area here, din din din, segment. Okay, the distance around the outside from start to finish, din din din, circumference. Okay, radius, distance all the way across, din din din, diameter. Now I'm going to leave this one for you because this is what the whole theory of area of that's an arc, by the way. Okay, so leave this one with you. I want answers flowing through. Okay, I want to be inundated with answers from all these infinite viewers at the moment. Okay, so this area here, what is the name of this area here? That's what I want to know. Okay, that position there. So I'm going to give you a second. We've talked about it today, and 3, 2, 1. Well done, Lydia. We've got the word sector. That is fantastic. So well done to Lydia for that. Okay, so going back to our little diagram we made earlier, back on route. There we go. So we've cut the circle up into sectors, repositioned them, half a circumference for the edge, pi r. That is so important just to understand where that's from. But this gave us the formula pi r squared, which is down here at the bottom. Pi r squared there. That's the one we want. So just to finish off, this is actually quite easy, really. So I want the area of this circle here. So I'm going to use my formula pi r squared. So what we need to do is substitute in the values that we know. 3.14 is absolutely fine. Remember, it's an approximate to correct to 2 decimal places, but that's correct. That's fine for what we want. Times by 4, times by 4. And that's all you need to do. You just need to learn that equation off by heart. And all the theory behind it, just really be aware of where the formula comes from. It's an awareness. I've not seen any GCSE questions asking you to prove it, but just having that awareness, it really gives you a few ideas. It makes the connection stronger and helps you to remember that where the formula's for. All right, so let's pop this in here. 3.14 times 4 times 4. Okay, that's 50.24. It is quite blurry today, isn't it? Just 1 second, see if we can make a little bit of an adjustment. Oh, that's better. Why didn't I do that before? Sorry about that, folks. All right, 50.24. There we go. So 50.24. There's a little bit of a focus on the top of there that's made it a little bit. So apologies about that. I must have knocked it earlier. All right. Let's go back to this diagram. This is probably a bit. Yeah, look how much clearer that is now. Oh, that's a shame that was blurry. All right, okay. So anyway, so that's 50.24, and put centimeters in, and this is going to be centimeters squared because it's area. Okay, so you get the right idea of what's going on here. That's the most important thing to remember. All right, and we're just going to leave you with one more question to finish off with. All right, and then we're done for today. Okay, so if I get a little circle going here, little question here, but this time I'm going to make it a little bit of more difficult. All right, so I'm going to set that up. I'm going to give you a sector. There we go. There's a sector there. I'm going to mark that at being 60 degrees, and this radius I'm going to give you at 5 centimeters. Okay, so I want the area of this sector. So we're going to use the formula area equals pi r squared. Okay, So welcome to Amith. What a star joining us this morning. Okay, so on to sectors. Welcome Amith. We've got a few people here getting involved now. The Maths Live fan club is set. It's really going. Okay, so back to this sector. We're going to do area equals pi r squared. Now that's the formula we've worked on, but we haven't got the whole circle. So I'll come back to this little section in a minute. But if we were doing the whole circle, I'd be typing in my calculator 3.14 times 5 times 5, or 5 squared. But we've got this little section here to think about. Now, we've got 60 degrees, and the key here is to remember that the whole thing, the whole circle, is worth 360. The whole thing is worth 360. And we've got part of that circle, we've got 60 degrees out of 360. So if ever you get a situation like this, what you need to think about is the fraction of the actual full circle. It's 60 degrees out of 360. So I can put that in earlier on. And actually, I can whack all of that in the calculator in one hit. Remember, if you've been watching my live maths, that's a really useful button to use. The fraction button there. 60 out of 360. Use the cursor to get to the middle again. Alright. Multiplied by 3.14. You can use that pi button if you want to, but 2 decimal places is more than enough. Times 5 times 5. Boom. So you've got that as a fraction. So convert it to decimals, and 2 decimal places is fine. So that's going to be 13.08. Okay, that 3 doesn't affect the 2 decimal places, so I'm missing that out. And it's a must to put centimetres squared. And also, bear in mind, folks, really good idea to put down how many decimal places you've rounded to, or you could look in the question and it'll be saying on there how many decimal places is needed. So that's it today, folks. Thank you for listening. Now just go through a couple of things before we finish off. So look out for the Maths podcast. That's just an audio that will be coming out at some stage and going on the Facebook site as well. And also it'll be next week now before I continue with the live maths, but I shall be continuing with the next theme. So keep your eyes out on the Facebook page for what's coming up next. But I'm just going to have a little bit of an Easter break, Friday, Saturday, Sunday, maybe possibly Monday, and then it'll be probably around Tuesday, Wednesday. I'll be getting back on board 10 o'clock usual time, and we'll get back to it. Any requests will be gratefully received. Okay, so without further ado, thanks for joining me, folks, and I'll be leaving you with a bit of 2001: A Space Oddity.